Welcome, Hornets, and thank you for joining me today. Today we're going to be taking a look at using IVT to prove that a value must exist. Now you'll notice in this question, one of the key parts that we have is that we have a twice differentiable function, and it is measured in inches. So if I have a twice differentiable function, that means that the function is by its very nature continuous, that its first derivative is continuous, and that it has a second derivative. Okay? So, let's go ahead and just ask the question, must there be a value of times c? So must there be a times c, or time t in this case, let's just say t equals c, such that r of c is equal to 7. See, that's the way the question's going to be asked. Now, if this is true, then I look at r of c and I say, well, we know that r of t is continuous, and I can see that it is bound by a 5 and an 8. And according to IVT, the intermediate value theorem, 7 must fall between 5 and 8. As a result, I will now use the sentence frame, yes, there must be a time c such that r of c equals 7 because r of t is a continuous function on the closed interval 0 to 3. Notice I use time. 0 to 3 is my interval. And we're now going to create our inequality. So if I'm looking at 7, I know that r of 1 is equal to 5, which has to be less than what we're looking for, r of c equaling 7, which has to be less than our r of, what is that, 2 equaling 8. And there is our sentence frame. Yes, there must be a time c such that r of c equals 7, because r of t is a continuous function, and use our English appropriately, is a continuous function on 0 to 3. Notice it's a closed interval, and we have the inequality. R of 1 equals 5 is less than r of c equals 7 is less than r of 2 equals 8. Now we could also do this for the second derivative. Must there be a time c? Let's do must there be a time d? Must there be a time d such that r prime of d is equal to 5. Well, when I'm looking at this, you'll notice I have an 8 and I have a 4. And therefore, by IVT, since this function is twice differentiable, and the second and the first derivative has to be continuous, just like the original function r of t is continuous, and it's differentiable over all of the values, I would say yes, and now I'm going to repeat this. Yes, there must be a time b such that r prime of d equals 5 because r prime of t is continuous on the closed interval 0 to 3, and the inequality r prime of 1 equals 8 is greater than r prime of d equals 5 is greater than r prime of 2 equals 4. Once again, you'll notice I'm using the sentence frame, and I'm able to use IVT because I know that the function r of t is a twice differentiable function over the interval from 0 to 3. Therefore, its first derivative has to apply, as well as the original. And we can also say that we have an approximation of r double prime if we wanted, but that's for another video. Alrighty, this is finding and using IVT to prove that a value exists from a table. I hope this has helped. If you found it useful and you liked it, please remember to click like. If you did have a comment about this or how I can improve, please feel free to leave a comment so that I can improve my videos and become better at it. After all, I want you to be successful. That is my goal. Thank you very much, Hornets. Please be safe and kind to each other. Please remember it is easy to be mean, so please work harder and try to be nice to each other every day. Cheers. Be safe. Bye-bye now.